Hey stats class, let's look at a problem from 10.1 that's happened. Let's walk through a correlation test. So I'm going to press stat, enter. I'm going to go up to the top of the list, clear it out. Make sure you're hitting clear, enter here, not delete. So up to the top, clear, enter. Alright, I just want you to see, if you ever accidentally hit delete, now it's L1, L3, you can always press stat, go to number 5, set up editor, and hit enter. And now your editor will be back and have L2 again. Alright, so it's not gone forever. You can always fix these things. Alright, I'm going to enter in the X's into column 1, enter in the Y's into column 2. Alright, once I've got that in there, I'm going to press second stat plot. So second Y equals, make sure that that's on. It is. I'm going to press zoom, number 9 on mine. I can actually just press zoom 9, but I want you to see that number 9 is stat, zoom stat. So there's what I see, and of these choices I can see that it is clearly D, right? So it has that bend in it, everything else does not. Alright, then it wants me to find the correlation coefficient. So the way that I'm going to do that is I'm going to press stat and I'm going to come right to calculate, and I'm going to come out to linear regression, number 4 right here, AX plus B. We're determining how well a line fits the data, and if I hit enter here, it wants to know what's the value for L1, what's your value for L2, so your X list, your Y list, L1 and L2 like we've seen before. But then we have this option to store the regression equation that we come up with. I encourage you to use this, especially for the 10.2 homework set. And the way that you're going to do that is you're going to press vars, you're going to come right to yvars function, just hit enter, and then where do you want to store it? So there's all these different y's. When you press y equals, that you have that option. And you can just tell it to put it in Y1 and then calculate. Now, when you have something called diagnostics on, you will see the value of R right here, and that's what I need. So 0.752. And by the way, if this is ever wrong, if that's ever tells you that's not correct, then most likely what's happened is you've got a typo in your data set somewhere. So I'm going to press stat, go to my editor, and actually it wasn't in what I put in. I put in everything correctly. It's this frequency list. I don't have a frequency list, so I need to delete that and come back down, make this again vars, yvars function y1, but leave the frequency list blank. I had an L2 there by accident, and now calculate. So now I can see R is 0.816 rather than what I had before. Alright, and now once we get the correlation coefficient correct, it wants us to determine, is there sufficient correlation. So I'm going to click this and show you this is what they're wanting it to compare us to, but with the R value that big, yeah, we're definitely going to. But our sample size was 11. You can get it from, when you do your stat editor, the bottom data point will have you see it has a parentheses with a number in the parentheses. Well, the last data point here is this one, and you can see it's the 11th data point. So that's our N. And at the level of 0.05, we're using this second column here. So this is saying our correlation coefficient needs to be higher than 0.602 for there to be sufficient evidence of correlation. And so since we are at 0.8, we are above that number. So there is sufficient evidence to support the claim of a linear correlation. So R is just for linear between the two variables. So even though, you got to understand here, even though that graph or the scatter plot looks like a nonlinear relationship, and it definitely is, R being 0.8 here, 0.816 measures the linear relationship. So there is evidence to support a linear relationship even though we're seeing a curve there. That's what R measures. So this is just showing you the importance of a scatter plot. So if R is 0.8, we're saying, oh, a line describes what we're seeing pretty well. And it does, the linear relationship. As X gets bigger, Y tends to get bigger, but we would completely miss that obvious bend and the return like it's coming back down. So the scatter plot shows that to us, that non-straight line pattern with that graph bending back down right at the end of our data set.